This is the third video on examples solving logs and exponential equations. I'm going to work through example 3 and example 4. In example 2, I'm going to solve the equation and round it to 3 decimal places. In order to get full credit for this, you should show all of your work. So you should show a fully simplified algebraic answer and then show the decimal equivalent. To start here, I need to isolate this term, because once that term is isolated, my exponent, which is a variable, I can then use logs in order to get that variable down from the exponent, and I can solve it. So to start, I'm going to add 4 to both sides. So I now have 2. 3 to the 2t minus 5 equals 15. I'm going to divide by 2 on both sides. 3 to the 2t minus 5 equals 15 divided by 2, which is 7.5. It's okay to use 7.5 because it's an exact answer, so that's fine. Okay, now I'm at the stage where I have something raised to a power with a variable in it, and it's equal to something else. In order to get that exponent out, I need to use the inverse property. So I'm going to take the log of both sides. In this case, the log needs to have the base 3 because that's what the base of the exponent was. So we would have log base 3 of 3 to the 2t minus 5 equals log base 3 of 7.5. The expression on the left simplifies to 2t minus 5 equals log base 3 of 7.5. And now I just need to work to isolate t. So I'm going to work by adding 5 to both sides and then dividing everything by 2. So after I add 5 to both sides and divide everything by 2, I end up with t equals log base 3 of 7.5. I added 5 and I divided everything by 2. So that's my exact answer. I then can put that into my CAS and I end up with 3.417. Just in case you need to see what it looks like on your CAS, I would actually start by putting it as a fraction. So I'm going to hit Control and the little division bar, so that gives me my fraction symbols. Then I hit the log button, and it's base 3. It's base 3, and then 7.5. And then outside of the parentheses is the plus 5, still in the numerator of the fraction, but outside of the parentheses, because only the 7.5 is, we're taking the log base 3 only of the 7.5, not of the 5 also. Divide the whole thing by 2. I just hit enter to make sure it looks like I want it to look, and there is my solution. Great. Okay. I'm now going to do B. I suggest that you pause the video and see if you can do it by yourself, and then you can follow along if you need help. So subtract 4. And that leaves us with 7. Divide by 6. So I get 7 over 6. Take the log of both sides. So I'm going to take log base 2 of 2t to the 5th, which means that I just end up with t plus 5 on the left, and I end up with log base 2 of 7 over 6. So what I did is I skipped this stage right here. I just went straight to the next stage. Then I'm going to add 5. So log 2, 7 over 6. Oh, I'm sorry, subtract 5. Subtract 5. And when you plug it into your calculator, you end up getting this as the result. All right, moving on to example 4. Example 4, our base is e, which means we're going to be using the natural log. So for the first one, basically I'm using the same steps, except instead of using I could use log base e, but instead I could just use the natural log, because the natural log is log base e. So I take the natural log of each side, and the natural log of e to the 4x is just 4x. Equals the natural log of 35. Divide by 4 on both sides. This is my exact answer. Use my CAS, and I get 0.889. Try B on your own, or you can keep watching. But I would start with simplifying. So divide by 4 on both sides. E to the 3x plus 4 equals 12. Then I'm going to take the natural log of both sides. When I take the natural log of the left-hand side, the only thing left is 3x plus 4. And on the right, I have natural log of 12. Now I'm going to solve for x by subtracting 4 and dividing by 3. So x is going to be natural log of 12 minus 4, all divided by 3. That's the exact answer. Then I use my CAS to get an approximated answer, and I get negative 0.505. Again, maybe try it on your own first. Start by adding 13 to both sides. And when I do that, I get 26. No, I don't. I get 52. Then divide by 2 on both sides. Now I get 26. So e to the 5x minus 7 equals 26. In order to get the exponent, in order to get the variable out of the exponent, I have to take the natural log of both sides, or log base e of both sides. So if I do that, I just get 5x minus 7 on the left, and I get natural log of 26 on the right. I am then going to add 7 and divide by 5. So x is going to be natural log of 26 plus 7, the whole thing divided by 5. And when I put that into my CAS, I get 2.052.